Karl Pearson's coefficient of correlation is also called product moment coefficient of correlation. So we have an example here where we are supposed to calculate Karl Pearson's coefficient of correlation. The formula for calculating Karl Pearson's coefficient of correlation is given as n summation xy minus summation x summation y over n summation x squared minus summation x squared. So it's important we write the formula first because it will give us a guideline as to which columns we shall need to make our calculation success. Now in this formula, n refers to the pairs of observations. In this case, we have 1, 2, 3, 4, 5, 6 pairs of observations. So our n is 6. We need summation xy, meaning we need column xy whose sum will be used here. Minus summation x, meaning we need column x whose sum will be used here. Then we have summation y, meaning we need column y whose sum will be used here. Summation x squared means we need column x squared whose sum we shall use here. Summation x means we need column x whose sum will be squared. So that's why we have these columns here. So you come up with a table of this type with these columns. After that, we take the values of x and y which we need to calculate their Karl Pearson's coefficient of correlation, and we write them down here. So that means we shall have the values of x located down here in the x column and the values of y written in column y. These values are gotten from the table we have up here. After that, we need column xy, which simply means you take a value from the x row times the corresponding value in the y row. So 21 times 8 will give us 168. 17 times 7 will give us 119, and we continue that way up to 10 times 2, which will give us 20. When we are done with that, we come to the next column, which is column x squared, and this will be found by taking the values in the x column, you square them. The first one will be 21 squared, which gives 441, then 17 squared giving us 289, and we continue downwards up to 10 squared, which will give us 100. Then we need column y squared, which will be found by taking the values in the y column, you square them. So the first one will be 8 squared, which will give us 64. Then 7 squared will give us 49, and you continue all the way up to 2 squared, which will give us 4. After you are done with that, then we need the sum of those columns. So the sum of column x will give us 139, sum of column y will give us column 55, the sum of column xy will give us 1624, sum of column x squared will give us 859, and the sum of column y squared will give us 699. When we are done with that, then we now write our formula. Say R is equal to n summation xy minus summation x summation y over n summation x squared minus summation x squared. So with that, then we substitute the figures. We shall have n is the pair of observations, and we said there are 6 times summation xy. Summation xy is 1624, then minus summation x, which is 139, times summation y, which is 55. So we have that 139 times 55 all over n, which is actually 6, times summation x squared. Our summation x squared is the total down here. That's 859 minus summation x squared, meaning we take this sum here and we square it. So we shall have minus 139 squared. Now, after we have substituted the values in the formula, the next thing is to simplify the numerator and the denominator. So on the numerator side, we shall have 1744 minus 7645, that being the product of this and this one respectively, all over 23,154 being the product of this minus 139 squared gives us 19,321. So if we simplify further, the numerator will give us 2099 over the denominator, which will simplify to 3,833. Now we express that in a decimal form. That will give us 0.548. That's correct to 3 decimal places. So that is how we calculate Karl Pearson's coefficient of correlation, which we also call the product moment coefficient of correlation.